All right, and we are back, and we are going to be going through our exam question 2. So, KV notation. Working with MgCl2, want to dope the material with this. Frankel defects, Canada defects. Frankel defects is this. Shock defects is 0.1, so that means that is our dominant reaction here because it has the lowest enthalpy of formation. Write out all the intrinsic defects, so we're working with that. So it is going to be, we're going to have a null goes to a vacancy in Mg. That's going to be 2 plus to 0 minus plus vacancy in Cl, which is this, 2 here. If you do Mgx, we're going to have vacancy in Mg plus Mg interstitial, 1, 2. And for Cl, Clx goes to vacancy of Cl plus Cl interstitial, dash. Excellent. And we know, again, the equation, here we go. Concentration of defects is approximately equal to exponential minus delta HF divided by KT. So lowest enthalpy of formation wins at all temperatures. Can I put an impurity atom on the X location in KV notation? Yes, that is what only can be put there, aside from vacancy. Can I put a vacancy on the Y? Absolutely not. Can I create a vacancy in my impurity for an extrinsic reaction? No, we can only create vacancies in the host. What about creating a vacancy in the impurity for an intrinsic reaction? So can I create a vacancy for an impurity? Well, that's kind of nonsense because there's no impurity for an intrinsic reaction. So no. Write a defect reaction that incorporates a cation substitutional. So let's go ahead. So we're doping the material with NCl5 into MgCl2. Cation substitutional. N is plus 5, Mg is plus 2, so that's going to be 1, 2, 3. So I need to now create plus a vacancy in Mg. That's going to be minus 2. So I'm going to do a 2 here. I'm going to do a 3 here. So that balances out my charges. Mg is 2 plus, that is that. So now what do we have left over? So I have 2. So I need a plus. I need 10 ClX. Yep, 2 N's, 10 there. How many Mg's do we have? 5. Done. What about a cation interstitial? So NCl5, MgCl2, a cation interstitial. N interstitial is going to be 1, 2, 3, 4, 5, plus a vacancy of Mg. That's going to be minus 2. Put a 5 there. Put a 2 here. 2, 5, plus 10 ClX. Done. And then finally, NCl5 into MgCl2. We need a... This is why it's good to... This needs to be an anion. And I'm opening up my computer right now because I want to make sure that I don't have this mistake. Let me fix this little error. Cation interstitial. We need, let's do an anion vacancy. So this needs to be an anion vacancy. So an anion vacancy would be a vacancy in Cl, which would be a positive. I would do plus an MgM, which will be plus 1, 2, 3, plus vacancy of Mg minus 2. I'm going to put a 2 out in front of there. So let's balance N. So I need plus 5 ClX. Mg, how many do we have? 3. So 3, and then Cl6. Done. That's it. That's our problem 2. Thanks, and see you next time. Bye.